Alrighty, we are going to practice recursive functions. So recursive functions means you are going to call upon your function within the draw function only once, but it's going to keep running until you tell it to stop. So it's going to create multiple shapes. And we're going to do this two different ways. So the first thing, regardless of which way you need to do it or you choose to do it, first thing you need to do is to create a new function. So we're going to call a new function. Let's call our first one repeat, right? Because our recursive functions are going to repeat themselves. And so we have those parentheses, and then we want to make sure we close it. Okay. So in this repeat function, what we want it to do is, first shape we're going to draw is we're going to draw an ellipse, or a circle, of course. And we're going to center it at x, y, with the diameter, let's just call it size. And so let's make those three variables. And this is, of course, our first ellipse, right? Because it's going to repeat. So those first three variables should be our parameters of our function. So x, y, and size. So then just to double check, if we call upon that function, so if we call upon our repeat function, and let's see, let's draw a circle at 100, 300 with a diameter of 200. Let's see where that gets us. Perfect. So sure enough, that gives us one circle centered at 100, 300 with a diameter of 200. Great. But what we want to do is we want to create a whole bunch of circles. So we don't want to stop it here. We want to create a whole bunch more. And you know what? Let's even make them get smaller than as you go to the right. Because we don't want to have to draw, okay, an ellipse here, and then another ellipse here, and then another one here. What we want it to do is we want it to just automatically go all the way across and keep going until we tell it to stop. So let's talk about that part first, when we're going to tell it to stop. We're going to tell our function to stop when our size, when our diameter is less than, let's say, 10. So we need to tell it, okay, keep running as long as the size is greater than 10, right? So if the size is greater than 10, then I want this function to do what? Well, what I want it to do is draw another ellipse, but I don't want to keep writing ellipse over and over because I want the function to do the work of running over and over and over. So what I'm going to do is I'm going to call upon the function. So as long as the size, the diameter, is greater than 10, I want it to run the repeat function, except instead of my x coordinate being in the same place, right, the center of the same one, let's shift it over to the right, and let's just shift it over by size, right? Because that's how big that first circle was. So x plus size, let's keep it in line though. Let's keep the same y coordinate. And then maybe we don't want the same size diameter. You know, we sure could, but then it's going to run forever and ever, right? Because the size isn't changing. And so what we want to do is we want to say, let's cut it in half, right? Divide by 2. So now what it's going to do is it's going to say, okay, as I repeat, or as I call upon my repeat function, I'm going to draw an ellipse centered at the parameters. And then, as long as the size is greater than 10, as long as the diameter is greater than 10, I'm going to run the function again. So I'm going to circle back to the top. I'm going to shift to the right, however big that first diameter was. And then I'm going to keep the same y coordinate, but my size, my diameter, is going to be half. So now when we run it, we should get this whole, yep, there they are, a whole bunch of circles to the right. And say you want those circles to be touching, then maybe you just kind of play around with, okay, instead of the whole diameter, let's only shift it 3/4 to the right, so 0.75. And that's just something you would want to play with, and sure enough, you'll get them to touch that way. Maybe you don't want them to cut in half every time. Maybe instead of dividing by 2, whoopsies, instead of dividing by 2, you're going to multiply by that 0.75, so you're just getting a little bit smaller. Oh, look at, and then they run off the screen, you know. So play around a little bit with that. And that's just our first function. That's one way to do it. So one thing we did is we just said, okay, when you call upon your function again, you're going to change those parameters, right? Because the x, y, and size are our parameters. So then we change them here. And that's one way we can do it. But you know what? We're going to silence that function. And we're instead going to run it a different way. So let's draw some rectangles this time. So let's say, let's call it squares, right? Because if we actually type in square, it would freak out. You have to call it a rectangle, right? And so we'll figure out our parameters in a second. We just want to close it, call it good from here. So what we want to do, we said, is we want to draw a rectangle. And then let's call it, or let's start it at the ordered pair x comma y. And then if we actually want a square, rather than giving the height and the width, or excuse me, in opposite order, right? The width goes first and then the height. So rather than keeping those two different ones, we want to keep those the same if it's actually a square, right? Let's keep the same parameters. Let's call it size. And so again, those are going to be the parameters of our squares function that we have named. So we want to start it at that x comma y, but notice we only need to call size a parameter one time because it's a square we want to be drawing. So then that's the same width and the same height. So let's just confirm if I call upon my squares function, let's center it at 100, 0, and then height and width of 75 should make a little square in the top left corner. Perfect. So now what we're going to do is, rather than changing the size, we can keep, we sure could. We could keep the size. We're just going to change the y-coordinate. Let's do a whole column of squares. So then, same idea. We have to run that if loop. So we're going to say if something is true, then we want it to do this other thing, right? So if what is true? Well, let's keep running these until we run off the page, because otherwise it'll run forever. So let's say if the y-coordinate is greater than 600, right? That's when we want it to stop. So this would tell it, okay, this is when we start running. That's not what we want. So as long as the y-coordinate is less than 600, then run this, right? And if it's not less than 600, it's going to stop. It's not going to run it. So if our y-coordinate is less than 600, we want it to run the squares function again. So we want it to run the squares function. And you know what? We're going to keep those parameters the same. But what we're going to do before we run this if function, or this if quandary, then what we're going to do instead is we're going to change our y-coordinate. So in between drawing that first rectangle and running it, or checking to see if we should run it again, we're going to change that y-coordinate. And what we're going to do is we're going to say our new y-coordinate is going to be our old y-coordinate, but shifted down by the size amount. So then we have, okay, great, calling upon our squares function, it's going to draw a square centered at starting at xy, and then it's going to go the same out and down, fine. But then it's going to change our y-coordinate, and it's going to say, okay, forget the old one. Now change it and shift it down by whatever that height was. And then say, okay, well, if that y-coordinate's less than 600, if we're still on the page, run it again. And part of running it again means it's going to shift it down again. So now when we run our squares function, it's not just going to have that function there, that square there. It's going to have a whole column of those squares, because it's going to keep running until we run off the page, until we get there. Now we can, of course, change the size as we go down like we did last time. So instead of just changing the y plus the y-coordinate, let's also change the size to be multiplied by 0.9. We're not going to get super small as we go down. We'll go down a little bit. And so you can also make them smaller that way. Well, that's kind of fun. You can change how you center it, right? Maybe shift the x-coordinate over as well. And then just one thing to notice, we could have done this for our circle function as well, right? There's just two different ways that you can do it. So you can either say when you call upon it within itself, within its own function, then you're going to change it there. Or you can say before I call upon it again, I'm going to change what those parameters were. Even though you only define them that one time, you're going to change them as you run the function. And either way it's going to work. You just have to kind of play around with it a little bit and see what works best for you. So I do have my open processing link posted here as well, but notice it's sketch 1971964. So if you'd like to take a look at these functions, I'll clean them up a little bit and then I'll post them as well. So good luck to you with your recursive functions.